Okay, so this lesson is for 3B. It's still part of interpreting graphs. So I'm going to be starting at this point, and it'll have the same objective as 3A, and I'll just jump to where the lesson will be connected for 3B. All right, so I'm going to start.
Before we go to our next lesson, this slide says, tell a story about this bus using the graph below. So you see a graph, there's a time for it's in hours, and then a distance in miles. And then you notice different lines that are plotted on the graph. So if you were to tell a story, and most of you will have different stories based on what's going on in the graph, that's fine. I'm going to say what I think based on this graph, my own story. So the bus is taking a bunch of kids to, I would say, a road trip. And it looks like it's going to be lasting 8 hours from the time that they start to the time that they end. So at the starting point, they're 2 miles away, let's say 2 miles away from the school. So now it seems like the graph is going up. So within that, it seems like an hour that the graph is going up. So I would say that the bus is in motion, it's driving, so an hour they're in the bus, sitting, talking, listening to music, whatever. From 1 to 2, the 2 hours, 1 hour, it stops. It's not really going anywhere because it's at the fourth mile of this trip. So that means I'm thinking either they got out of the bus, they're looking at the site, whatever site it is, stretching their legs, talking about the site. Maybe the teacher's asking them questions like, certain things about the site, and they have to try to answer it. All right, an hour passed. Now the bus everyone gets back on, they're going, they're driving, it's an hour, and they've done 8 miles in that hour. All right, so now the bus stops at the 12th mile, and for an hour, they're stopping at another site. Talk about it, questions, all that stuff, and maybe they're eating their lunch or snack or whatever they have while they're looking at the site. So this is for an hour. Now the bus continues for another 8 miles. Then it seems like for 30, let me see. Yeah, maybe around like 30, a little more than 30 minutes. They are either looking at something or they're getting a pit stop. In the bathroom, grabbing something to eat, buying something, or checking out a local site. Now, based on the graph, it looks like it's going down. So I'm going to perceive it as them going back to the school. Because they were going away from the school, and now they're going to go back. So it takes them 16 miles. 16 miles, the bus keeps on going. It's almost maybe for an hour, or a little less than an hour. Then they stop for a pit stop. Maybe there's another site. Because it seems like around the 4th mile, they stop. Maybe they the bus driver took another route to go back to the school, and now they're seeing something different in that 4th mile. And then also maybe they have a snack, or they're eating, or the pit stop, goes to the bathroom. And now they're on their way back to the school for 4 miles, and it takes 30 minutes. And then at the 8th hour, they're back to the school and ready to go back home. So that's how I would be telling a story based on this graph. So this leads us to our next lesson, which is interpreting graphs. And the objective is, how do we interpret graphs and represent relations as sets of ordered pairs, tables, mappings, and graphs?
Okay, so like I said, lesson 3B has the same objective as 3A, and I'm going to jump to where I will be talking about graphs. So let me get to that point. Hopefully I stop, so bear with me. So if it catches whatever from the last lesson, just either ignore or let it pass, and then it'll get to where we need to be.
The graph, we have mapping, and we have the ordered pairs. Okay, so now, when it comes to interpreting graphs, the function can tell you a story, which can be told using a graph. These graphs do not need a scale on either axis to show the general shape of the graph that represents its function. So here, it says a graph at the right represents the speed of the school bus traveling along its morning route. Describe what's happening in the graph. So they already labeled what's going on. They said at the origin, the bus is stopped. Origin is 0, 0. It accelerates and maintains a constant speed. So the bus is accelerating. Notice that the graph is going up, the line is going up, it's accelerating, and then when it stays at a certain, when it's horizontal, it's maintaining speed. It's a constant speed that's going on. So then it begins to slow down. As you can see, the graph is going down, it's deaccelerating, and then eventually it stops over here. After being stopped for a short time, see there's no motion going on, then it accelerates again, and then it accelerates again. The starting and stopping process repeats continuously. So just think of it as the bus picking up people at certain stops. So it starts up, maintains the speed, slows down when it sees someone at a station, stops, picks them up, and continues the whole process. So that's how you would read this type of graph. And it doesn't have to be just for the bus movement. You could make a story about anything using that graph. But it has to make sense based on what's going on with the graph. There has to be some connection. All right, so now the next one, it says, identify a graph that represents the altitude of the space shuttle above Earth from the moment it is launched until the moment it lands. So we have 3 graphs, and it's showing time and altitude. Altitude is height. So now we need to find a graph that represents the moment that the space shuttle launched, and then it comes back to Earth. So which one would be the best one? Graph A, B, or C? If you said graph A, you are correct. And graph A, because it says, before it takes off, the space shuttle is on the ground. So it started at point 0. Ground zero, I could say that way, ground 0. Then it blasts off, so that means it accelerated up to the sky, gaining altitude, until it reaches space where it orbits the Earth at a constant height. So this is when it's in space, and it's just orbiting around the Earth. Then it comes back to Earth, so it's going down until it gets to, it lands, whether in the water. Most of the time, these space shuttles, the capsules, end up landing in the water. So graph A would be the best representation of that story. Here, graph B is just showing that means this space shuttle is still out in the universe, and there must be a problem because it can't come back to Earth. And it shows that the space shuttle started outside in space, and then it's coming back down. But we're looking for where it started on Earth and then come back to Earth again. So A is the best representation. All right, so we have more vocabulary words. Independent variable and dependent. Independent variable is the value of the variables that is subject to the choice. That means domain values. So anything dealing with the x values, these are the independent values. Dependent variable is variables of the value of the variable that can change based on the value of the independent variable. These are your range values. So basically, with x and y, whatever you do to x, it will give you your result, which is the y. So whatever you input for x, it will give you your output, which is y. And x usually stands alone because x is not affected by anything. X is the master. If you want to think of it, it's like is in control. It's the one that is the boss. So whatever X says, then the Y's will follow based on what X produces or what X does or says. Y is dependent on what X has to say or do. So that's why the Y values, the range values are dependent and the X are domain. That's one way you can think of it. So for example, generally the average price of going to the movies has steadily increased over time. Which is independent, time or price? If you said time, you are correct. Time is the independent value because the price increases as time goes by. So if you, for example, the average ticket price in 2000 was $5.39. This is the average ticket sale. But in 2019, the average was $9.11. So notice as the time increases, 19 years later, the price increases. So it's based on the time. Right. So we gonna have three graphs that we're gonna look at. And the first one says the graph below represents the height of a tsunami, a tidal wave, as it approaches shore. Describe what is happening in the graph. So we're going to be describing what's happening. So each of you will have your own different interpretations as long as it makes sense and it's accurate. For me, I would say that at this point, the zero, the origin, so let's say it was 1 o'clock. The height of the wave was barely there. The lake, the ocean was calm. Also, as time passed by, let's say maybe within the 15 minutes, the height of the wave got taller, 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 taller. So that's how I would be describing this graph. So basically, as the time passed on, as 30 minutes, 15 minutes passed on, it reached a height of 20 feet. At this point, you see that wave coming towards the shore, you better run. You better be far away before it even hits that height. Right, next one. The graph below represents a student taking an exam. Describe what is happening in the graph. So again, you're going to have your own interpretation, which is fine as long as it's accurate and it relates to what's happening in the graph. Here's my description. So we have a number of questions answered and then a time. So let's say I'm the student and I'm starting off at the same time as everyone else. So this line tells me that, okay, I've answered 5 questions within the 5 questions in 3 minutes. Those were the easy questions. Then I got to the next question and I'm stuck. It's taking maybe like, I don't know, 5 minutes stuck on one question. I mean, I could have moved on, but I want to answer this question, not leave it blank. So that's the time that it took me to answer the question. Now I'm on a roll. The other questions, yeah, maybe they're a little challenging, but I'm like, I get this. I can do this. So I've answered maybe 5 more within a short amount of time, like 3 minutes. Now I'm stuck on this hard question. Because look at the line. It's longer than this one. Maybe it took me 10 minutes. Wow, that would drive me crazy. 10 minutes to answer this one difficult question. Or maybe there's parts to it, and it takes me time to do each part. And then now, after I've passed this hump, I'm zooming by with all the other questions because maybe I have like 10 minutes left, and I need to like get this going and finish the test. So that's how I would describe graph number 2. The last one is example number 3, and it's dealing with forest fires. So forest fire grows slowly at first, then rapidly as the wind increases. After firefighters answer the call, the fire grows slowly for a while. But then the firefighters contain the fire before extinguishing it. Which graph represents this situation? So we have 3 different graphs, and we have to find the one that best works this story that we just looked at. So we know that the fire grew slowly. So that means this forest started at a point. It was little and it started to grow. This would not be answer. So we have down to B and C. So they're both starting at a starting point. And they both are increasing slowly, which is showing that. But now it says, then rapidly as the wind increases. So we see this happening, but then this one has the steepness of this is a little bit steeper than this increase. So I would say B, and let's see if it matches what the rest of the story says. After the firefighters answer the call, the fire grows slowly, as I can see over here, for a while, but then the firefighters contain the fire before extinguishing it. So that means slowly the fire is dying, and then it's gone. So B would represent, so I'm going to circle B, represents the graph that best connects to what we read. Right. So we are at the end. So we learned about different types of relations.
All right, so I'm just going to end it here because this was connected to 3B. You already did the other stuff from 3A. So if there were any questions with interpreting graphs, you feel free to email me and I can clarify things for you. All right, so I'm going to end this and see you next time.